Hello and welcome to Chapter 3, Supporting Processors and Upgrading Your Memory. All right, before we get started, I just want to remind you that I'm going to ask you to take some notes and you upload those notes as homework. Okay, now, before we begin, I want to explain to you what the CPU and the memory has to do with each other because it's very, very important to understand. So if you can, please write the following down. I'll speak slowly. You can actually hit the pause button if you need to. The CPU, which stands for the Central Processor Unit, it is the brain of the PC. The operating system fetches the files from the hard drive, converts the files into machine codes. We call that opcode, so you can put that in parentheses, and places them in memory. So the operating system takes the files from the hard drive and puts them into memory. Once the data is in memory, the operating system then sends the data from the memory to the CPU for processing. The CPU processing, interprets what these codes are. This is called a thread. Thread. So when the operating system sends those threads to the CPU interprets those data. Once the CPU interprets the data, it will instruct the operating system to do something with the output. So that's really the process. So therefore, the CPU interpretation, which is processing time, depends on the CPU frequency. We also call that computing power. The faster the CPU frequency, of course, the better. The faster it's going to interpret or process the data. The more memory you have, the more space the operating system will have to open up more data. So you can open up more application at the same time. That's called multitasking. In addition, because it's much faster to process data from memory than the hard drive, the more memory you have, the faster the CPU will process the data, of course. Okay, so that's important to understand as well. All right, there are two major manufacturers that manufactures CPUs, and they are, you probably know them already, the Intelligence Electronics, short for Intel, and the other one is the Advanced Micro Devices, AMD. All right, so let's take a look at some of the features. There are 4 features of a CPU we should include: the processor speed, lithography, which means the space between the transistors. That can be in nanometers. Nanometers is 1/1000th of a meter, extremely, very, very close to each other. That's why, they do them in clean rooms. The socket and the chipset that the processor can use, and the multi-processing abilities. Okay, so write these down as well. The 4 features of a CPU includes the processor speed, lithography, socket and chipset processor, and the multi-processor abilities. All right, hyper-threading, another definition you should know about because you'll hear that a lot when we're talking about CPUs. Hyper-threading is the 2 logical processors for each physical processor unit. So it's really a software kind of to allow you to have like 2 processors instead of 1. Multi-core processing, you may contain, that's physically you can have up to 8 core processors. Dual processor will have 2 processors, for example, sockets on the motherboard, as you can see right here. All right, what else do you need to know? The CPU features include what type of memory it has, it supports, does it support virtualization? Is there an integrated GPU? GPU stands for Graphic Processor Unit. If you're really into gaming, you probably want to get something that is external, a peripheral, that you can buy a GPU and put it into your PCI slots. But those are very expensive, number one, and they consume a lot of power as well. And can your processor do overclocking, which I highly don't recommend. I don't recommend that. All right, I think we discussed that on the last chapter. All right, another thing you should know about, and I want you to write this down, a 64-bit CPU means that the CPU can process 64 bits at a time instead of 32 bits. That's twice as much, right? Right down here. So 64-bit processor are much better than 32-bit processor. In fact, a 64-bit processor allows you to have a lot more memory on the motherboard than a 32-bit. All right, so let's get into the actual processors. Let's take a look at the Intel processors. There is the latest and the greatest 9th generation, which was released in 2017. I think it's in Chapter 2 when we talk about the Coffee Lake. And there is the Core i9 and Core i7 are made for high-end desktop and laptops. So if you can get one of those, that's really nice. The latest Core i9 processor had 18 cores. So you can have up to 18 processors, 4.2 gigahertz and 24.7 megabyte of cache memory, which is great. You know, cache memory is used to cache in all the applications that were previously ran. So this way, booting up becomes much quicker. The more cache memory you have, the faster you boot up your system, the faster application will open up, especially applications that were previously opened. Core i5 is well suited for mainstream desktops. So most desktops today have i5 processors and laptops as well. Core i3s is for entry-level processors, if I'm not mistaken. So that's also good to know. Now, the AMD processors, they have the Ryzen Pro, Ryzen Threadripper, and a whole bunch of, and typically AMD processors are a little bit less expensive than Intel. All right, so let's talk about installing, right? Selecting, well, how do you select? Well, select the processor. It all depends on the motherboard that you're going to have and what you are going to, and how much money you really need to spend. All right, so now let's talk about installing a processor. Make sure the first thing you need to do when you are installing a processor is, of course, to wear a wrist strap. This is to prevent the electrostatic discharge. Make sure also that the power is turned off, right? Don't ever work inside the PC with when the power is on. All right, installing a cooler. Sometimes coolers are lightweight with heat sinks and fans on the top. Some are heavier, by the way, reading this right off of your notes, right? Some of them are heavier with heat sinks, fans, and fans on the side, and they require a plate installed on the bottom of the motherboard to strengthen the board for a heavier cooler. You may need, by the way, to add some thermal compound on the CPU to have the fan sit on top of it, to stick on it, okay? Make sure you replace a CPU on the laptop. Replacing a CPU on the laptop may not be cost effective, by the way. And the reason for that, because it might be a little bit too expensive to do, it's not worth it because you have to rip everything apart and to really get there, and replacing the CPU on a motherboard, on a laptop, might be a little bit too expensive. It's probably a good idea just to get just depending on how old the laptop is. All right, so all these pictures that you are seeing right here is how to replace the fans on top of the CPU, so it can suck the air out. There are heat sinks, not necessarily fan. Those metal pieces that sucks the air out, and the fan inside will blow the hot air out. So when you are installing the CPU, make sure you check the pins, and there's a notch in here that makes sure it matches on the other end. This is the ZIF socket. You pull that lever out, you put it in, and when you bring the lever down, the holes in the socket will grab onto the pins, and you can't make a mistake with these. All right, moving on. So here's the adhesive that you have to put in there to put the fan on the top so it can stick. Make sure that it's powered. This is inside the laptop. This is the processor fan. Here's the processor heat. Okay, this is just an example. You know, all laptops may look different, but they are compact. And the CPU, again, might be very expensive to change the CPU itself. So you have to think twice about doing that unless your laptop is really at the high end and you want to change it. I find it very seldomly that anybody actually changes the CPU on a laptop. Even on a desktop itself, it might be expensive. On a desktop is a little bit different because a lot of desktops, high-end desktop, may have very expensive GPUs and memory, and you know, it might be worth it to change or upgrade the CPU. But I don't know about a laptop. All right, so again, make sure you have a wrist strap. Even when you are opening up the PC, never ever touch the pins on the CPU if you are changing them. All right, so be very careful. Try not to do that. Okay? All right, now let's talk about memory. So here's what I want you to write about memory. Again, write these down. So this way we are very careful. I want you to write it down so you can hit pause if you need any more time. All right, DRAM, dynamic, which stands for dynamic. I want you to write this down, right? Dynamic random access memory. Now, DRAM loses data if the power is turned off. The DRAM is made up of capacitors. A capacitor either holds a charge, that's like a 1, or don't hold a charge, that's a 0. To make sure that the capacitors always hold their charge constantly, a circuitry on the motherboard must keep refreshing that data to keep the 1 a 1. If the memory is being refreshed constantly, you know, there's a refreshing rate that's the DRAM has to go through, then the processor has to wait until the refreshing cycle is done before it can fetch the data. On the other hand, there's something called SRAM, static RAM. Write this down as well. SRAM is made up of transistors. Unlike capacitors, transistors will hold charge and do not need refreshing. Therefore, accessing data from an SRAM is faster than accessing data from DRAM. Cache memory and ROM, read-only memory, is an example of SRAM. All right? So we'll stop right here and we'll continue with memory on the next video. All right? Write everything that I told you and upload that as homework. I'll see you on the next video.